Hey guys, we are working on a triangular prism right now. We are going to go over surface area, volume, and then do one example. To begin this problem, I'm going to start off by redrawing a triangular prism and giving you guys some pointers. So whenever I draw a prism stacked vertically, like this one, I'm going to make mine a little wider and flatter, but I draw an oval, whether with my mind or with a pencil, or in this case a highlighter. Then along the circumference of this circle or oval, this is really like the type of circle you would draw for the top of a cylinder, where if you looked at it from bird's eye view, it would be a circle, but looking at it from the side, it kind of looks like an oval. Then around the circumference, I'm going to plot 3 points to represent the vertices of the triangle. And I always try to make sure, just for visual effect, that you don't put any 2 points, no matter how many vertices your shape has, you don't put 2 points on the same horizontal or vertical line, and it kind of helps it look a little bit better. So there we go. And then I'm going to draw my base. And from there, we draw our height. And connect those. Now, the reason I draw it this way, as I've mentioned in other videos, is kind of like a little slice of cheese or something, is because when you are going to be drawing pyramids, this comes in really handy. So you'll see what I mean when we get to those. Now, in the highlighter, I'm just going to highlight the edges. These are called edges that are able to be seen from the front. And the ones that are not highlighted are really the ones that I would normally draw dashed. However, I just didn't draw it that way. Now we can label a few variables on here if we want to. They are labeled here, and I even color coordinated from here to there. A, C, and B. This is B as in more like base times height, but they're calling it base times length. You might call this base times height, 1/2 base times height because it's a triangle. Of the base, and then this is the height of the prism. Hopefully that makes sense to you. A and C, because then the triangle has perimeter edges A, B, C, because you can't always find the area using 1/2 base times height. What if I don't have that information? A, B, C comes in handy because you can use them for Heron's formula to find area, or if you have an angle, you can use trigonometry to determine the area of the triangular base or face, whatever word you want to use. Also handy because we need the perimeter of the triangle, A plus B plus C, to unravel this triangular prism and find the area of the rectangle that would be made from these edges right there. So let me show you just a bit what it is I mean. Okay, so here I built us a little model of this guy right over here. So blue, yellow, green, and it basically, without the top and bottom, is the prism, okay? So the lateral area, okay, is really this, that, and that. So could you do a base times height and another base times height and another base times height and add them all up to get your lateral area? Sure, but if you unravel it and kind of think of it like this, you could just do one big base times height. So the height, the pink, is always the height. The base is A plus B plus C. So the perimeter of the base times the height gives us our lateral area. So let's do the example right here. We're going to find the surface area and volume, but let's write out our equations kind of as we talk through them. So the surface area is the 2 areas of bases, that's this whole part and this whole part, the triangles, plus the perimeter of the base times the height, which surface area equals, based on this picture, 1/2 B times L, that's your base times height, plus your perimeter, which is A plus B plus C times the height. So that right there is surface area above this little cloud, Obviously, it's a little bit more general and this more specific. The volume, I'll write over here. So the volume is really the area of the base times the height. So if you imagine you had a stack of triangle Post-its and makes like a tube, but not round, of those, you find the area of one triangle times the total height, and it gives you the volume. Now, what's the area of the base? Volume equals, there's that 1/2 base times height, or in this case, B times L, whatever letters you use is fine, times the height. Let's do the example in that corner. Surface area equals 12 is the base, 8 is the length or height of the base, if you will. Even though I know, like in this picture, it's resting on a rectangle, the rectangle is still not the base by definition. So it's not the base. This is considered the base. The base is the shape that keeps repeating itself in this little Post-it pile. So area of the base, so it's going to be 1/2 the base of the triangle, 12, times height, which is 8, that, times 2, so really those go away, plus perimeter, times height. Now we don't have the measurements of the perimeter, so really we can't completely do the surface area. So I'm going to keep this general, and I'm going to call this A, and I'm going to call this C, and it's not going to quite finish. So we're going to have 12 plus A plus C, perimeter times height, which is 20. 12 times 8 is 96. Now this right here, we could make up numbers for this example, so keep in mind they are not necessarily congruent, and they have to work with the Pythagorean theorem depending how you split up this 6. So if we pretend, because it's not necessarily true, that it's coming straight down the middle, that would mean it's an isosceles triangle. If that's 6 and 6, 6, 8, that would be 10 and 10, because it's really a 3, 4, 5 triangle, Pythagorean triple. So we can pretend right now, but please keep in mind that this doesn't necessarily go to the center. This is not necessarily 6 and 6. It could be 7 and 5. It could be decimal, increments. So we're just going to make believe. 10 plus 10 is 20, and 12 plus 20 is 32. 32 times 20, well, 32 times 2 is 64, so 640. 640 plus 100 is 740. Take away 4, because we're 4 short, is 736. So there is the surface area. And it would be centimeters squared. Okay, let's do the volume. Area of the base again. Times the height. 12 times 8 is 96. Half of 96 is 48. Or actually, let's do it this way. I'm going to take the half of 20 to make this 10. 96 times 10, 960. That's a little easier. Centimeters times centimeters times centimeters. Centimeters cubed. The volume is 960 centimeters cubed. So even though this could be different, the volume will stay the same, which is pretty interesting. So if this 8 centimeter orange line went down and this was 5 and 7, then these would each be different. This whole shape would be slightly different, but the total volume would be the same. It would not impact that. So I hope this quick little example was helpful and that you are able to understand the surface area and volume of triangular prisms a little bit better.